Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome back to Wednesday Night Math. I am Amy Singh, and I am one of the math specialists here at the Learning Liaisons. And every Wednesday, we are here just working through some math problems to help you build your confidence and competence in that math so that you can walk into that test prepared. We know these tests are not easy. We know they are difficult. We know they go in and you go in feeling so confident and then it just stumps you. And so that's why we are here. We are here to help you feel more confident, but also build that confidence in you as well. I will go through a variety of problems for pre-K through 12. If there is something specific that you want to see me go over in the coming weeks, please let me know in the comment box. I'm happy to do so. I always have a next week section, and in this section, as I monitor the comments, I will add things that you think that you are commenting that you want to see in the upcoming weeks. You can also tag me on our Facebook page, and I'm happy to add anything as you're studying throughout the week. If you're like, oh man, I was studying this problem, I really didn't understand how to do it, or I'm really struggling with this specific concept or whatever, I'm happy to include any of that in upcoming weeks because these sessions are for you. As much as I love sitting here and doing this every week, these sessions are for you. So they are for me to be able to help you and for us to be able to help you build that confidence and confidence. So if there's something you're struggling with, let us know and I'm happy to add it into our upcoming weeks. I always like to do a get to know you. It makes it feel a little bit less like we're all sitting in front of a computer screen and makes it feel a little bit more like maybe we're at a coffee shop doing math together or something like that. So in the comment box, let me know where you're from. Let me know what test you're prepping for and what are you up to this summer? Real chill question this week, but what are you up to this summer? Are you guys traveling? Are you hanging low, staying low, enjoying kind of the quiet of the summer? Are you jet setting around the world? Are you going to the beach? What are you doing? We are kind of laying low this summer. Some summers we are doing all the things, but this summer we are enjoying all the things that Orlando has to offer because I am from Central Florida. And so there's ice skating at the RDV, and there's Disney, and there's splash pads and the zoo. And so we are just enjoying all of those things in between work, which has been so fun to see through my little one's eyes. And so that is what we are doing. So I can't wait to see what you are doing this summer. I can't wait to see where you are from. We are going to jump right into a question that was specifically requested by somebody in this group. And so we are going to jump right in. Question 1 is something that was specifically requested. So let's go ahead and get started. Problem 1. During a math lesson on place value, a teacher observes that several students are struggling to understand how the digits in the number 243 represent different values. To support their understanding, the teacher should do which of the following? A. Provide base 10 blocks for students to manipulate. B. Encourage students to sketch their work. C. Model for students and then practice identifying the values each digit has. Or D, gradually release responsibility to students in their understanding. So this problem is extremely interesting because none of the answer choices are inherently the wrong strategy. However, we have to choose the best of what they've given us. And that is where these tests are really difficult, is when you read them and you're like, man, all of those are pretty good strategies. I don't know which one to choose. So we are looking at several students that are struggling to understand how the digits in the number 243 represent different values. And we are trying to support their understanding. And so the teacher wants to know what she should do. The answer here we're going to identify the answer and then we'll work backwards. The answer is A. Provide them with base 10 blocks to manipulate and then move forward from there. This problem indirectly supports the idea of concrete, pictorial, abstract. You'll also see it written as concrete numerical abstract, but it's a thinking model that we can use in mathematics, and it really supports student understanding. So we want to start every concept with a concrete model for students to understand. Concrete meaning I can literally build it, play with it, touch it, manipulate it. It's that tactile learning. So this is really kind of like today's version of the different forms of learning, right? So this is something that is tactile. It's those manipulatives. It's the ability to represent it using some sort of manipulative. And so by using base 10 blocks, the student can literally build the number 243. If they want to sit there and count every single unit until they get to 243, they can. If they understand that one block equals 100, then they can start from there and they can go 100, 200, 210, 20, 30, 40, 241, 242, 243. So they can build it with a base 10 block. And then after they build it, the teacher can say, okay, how many hundreds do we have? 2 hundreds. How much is that worth? What is the value of that? And then we can say the value of that is 200. That's how much I have in there. How many 10s do I have? 4. How much is that worth? 10, 20, 30, 40. It's worth 40. So by being able to build it and visualize it, it's pulling them back to that concrete understanding, because what we know is that they definitely don't have the abstract understanding. Students are struggling to understand how the digits in a number represent different values. And so we want to go back to that concrete. And if they quickly understand it, let's say you go back to concrete and they show mastery extremely quickly, you can quickly move right into that pictorial representation or numerical representation and have them draw it out. That would be letter B. B would fall into that pictorial understanding. Now, Could you go to picture first, and then if they're still not understanding, go back to concrete? You could, but I always like to say we want to go all the way back to concrete, and then if they get it quickly, we can move forward rather than constantly trying to step back to see where they're at. I would rather give them a level of success, and we, testing wise, would rather give them a level of success by going all the way back to concrete and having them feel success, and then we quickly move into picture, then go back to picture and they still don't understand, and then go back to concrete. And at that point, they're just frustrated because they've done so many different repetitions in a continuum working backward that they're just frustrated and they don't feel successful. So if we can go back to concrete, give them some success, and then move back into picture and then abstract, then that's what we want to do. Model for students and then practice identifying the values each digit has. Yes, modeling for students is a great strategy. And then practicing, it's a great strategy. But to support their understanding, we want to get them to a place of understanding, which is why we want to go back to those manipulatives. And then gradually release responsibility to student in their understanding. That's what you're already doing. And so you want to identify an actual strategy the teacher can use, like providing those base 10 blocks. So this concrete picture abstract model, we often think works so well with pre-K through 3, but really this is a model that works for all students, and it's really the understanding model that we want to use with all students. Questions about that? There are some great videos out there. If you just Google like CPA math model, concrete picture abstract math model, there are some great videos out there that kind of reinforce this as well. All right, let's move on to problem number 2. Below is an example of a student's work. 5/8 minus 3/4 equals 2/8. 6/12 plus 4/10 equals 10/12. 7/8 minus 4/5 equals 3/8. If the student continues making the same error, the student's most likely answer to the problem 11/15 minus 3/5 would be what? I absolutely love these kinds of problems because it doesn't just force us to look for student error, but it actually forces us to anticipate what they're going to do next, which really shows a level of understanding of the content and the pedagogy. So we have to figure out what the student's error is first before we can figure out what the student even did. So they did 5/8 minus 3/4 equals 2/8. They did 6/12 plus 4/10 equals 10/12. And they did 7/8 minus 4/5 equals 3/8. So I'm going to look at the first problem and try to figure out what they did here. It looks like they did 5 minus 3 equals 2. Is that something that they did in all the other problems? Did they do a subtraction problem in the numerator to get the numerator of my answer? 6 plus 4 equals 10. Yep, they added those because the symbol in the middle is an addition sign. 7 minus 4 equals 3. Yep. All right, how did they get their denominator? 8, 8. Okay, it looks like they kind of just maybe took the first denominator. Let's see if that's what they did and moving forward. 12, 12. 8, 8. So they took the first denominator as the answer. So 11/15 minus 3/5 would equal this first denominator here, which would be 15, and then do the operation just to this right here. So 11 minus 3 would be 8. So the answer to this problem would be 8/15. They did not ask for the correct answer. Now, let's just talk about what that correct answer would look like because some of us struggle with adding and subtracting fractions. 11/15 minus 3/5 actually equals what? Let's talk about that. we have to get common denominators to be able to add and subtract fractions. So how am I going to go about getting a common denominator for this? Well, 15 is a multiple of 5, which means I can actually just manipulate one of my fractions to get a correct answer. So I could do 5 times 3 and 3 times 3. Why do I multiply them both? Because then I'm technically multiplying this fraction by a value of 1. And anything times 1 is itself. That's really all I'm doing. 3 divided by 3 is 1. So I have 11/15 minus 3 times 3 is 9, 5 times 3 is 15. Now I can just add or subtract my numerators because my denominators are staying the same. With the same denominators, it's like adding or subtracting apples and apples. But with two different denominators, it's like trying to subtract or add apples and oranges. It just doesn't work. So 11 minus 9 is 2. So the real answer to that problem would be 2/15. The most likely answer for the student would be 8/15 based on the errors that they made in the first 3 problems. Problem number 3. Solve for x. 2x minus 3 divided by 5 equals 7. 2x minus 3 divided by 5 equals 7. So this is a pretty straightforward problem. It doesn't really require a whole lot of pedagogical thinking or error analysis, but we do have to know how to solve a problem like this if we're going to do it. So 2x minus 3 divided by 5 equals 7. How do I solve this? By using inverse operations. So the inverse operation for addition is subtraction. The inverse operation for multiplication is division. The inverse operation for a square root is a square. So in this case, I need to unlock or get this x out of numerator jail. So how do I do that? Well, I need to multiply both sides by 5 because right now this numerator is being divided by 5. So to undo that, I can multiply both sides by 5. These 5s cancel out and I'm left with 2x minus 3 equals 7 times 5, 35. Now that I've done that, a lot of you are probably feeling a lot more confident about this. Do not be intimidated by rational expressions, which is really what we just saw here. This right here is a rational expression. The fancy name for a rational expression, or the fancy name for a fraction is a rational expression, right? It's just an expression that has something on the top and something on the bottom. Now I can just solve for x. In order to isolate this x, I need to add 3 to both sides because right now it is subtracting 3. 2x equals 35 plus 3 is 38. Because the x is being multiplied by a 2, I'm going to divide by 2 on both sides. And so I get x equals 38 divided by 2. $19. So our answer for this problem is D. Now, I am actually going to copy and paste this. And I want to show you a different way to solve it. Let's say you looked at this problem and you were extremely intimidated by it, which happens to all of us. I'm telling you that right now. It happens to everybody. So that's not abnormal. But let's say you look at this problem, you're super intimidated. You're like, I don't know what to do. Use your answer choices to help you. I could easily take this problem and plug in each of these answer choices in for X. And when I plug it in, if it creates a true statement, that's my answer. If it creates a false statement, it's not my answer. So let's plug in 16 first. 2 times 16 minus 3 divided by 5 equals 7. I keep everything the same other than substituting X in. 2 times 16 is 32. 32 minus 3 divided by 5 needs to equal 7. 32 minus 3 is 29. And 29 divided by 5 is not 7 because I know that 35 divided by 5 is 7. So I don't even need to use my calculator or solve this. I already know that that is not the correct answer. Now, I'm going to do 19 only for the interest of time. We don't need to go through all the incorrect ones, but I want to show you what happens when we get the right one. So 2 times 19 minus 3 divided by 5 equals 7. 2 times 19 is 38. 38 minus 3 is 35. And 35 divided by 5 is 7. 7 indeed equals 7. So the correct answer here is going to be D because it creates a true statement. Because it creates that true statement. All right, let's go ahead and move on to problem number 4. A rectangle has a length of 12 centimeters and a width of 5 centimeters. What is the length of its diagonal? What is the length of its diagonal? So the first thing I'm going to do, anytime I think about geometry, look at geometry, smell geometry, I'm going to draw a picture. So this tells us that a rectangle, I'm going to start with a picture of a rectangle, has a length of 12 and a width of 5. Does it matter if you put the 5 up here and the 12 down here? It really doesn't matter. So you don't need to stress about, oh man, I thought length was here and width was here or whatever. It doesn't matter. What is the length of the diagonal? So they want to know what that value is. Now, if they asked for perimeter, we would do 12 plus 12 plus 5 plus 5. Why? Because perimeter is the distance around the shape. We are looking for the diagonal. So that really doesn't help us, but I wanted to throw a vocabulary word at you so that you kind of just got a little bonus lesson there. How do I find the length of a diagonal? Well, the first thing I notice is that I've got a triangle here, don't I? This is a triangle. And more specifically, it's a right triangle. What does that mean? What does it mean that I have a right triangle here? It means that I can use the Pythagorean theorem. A squared plus b squared equals c squared, where c is your hypotenuse, which is across from the 90-degree angle. And everything else are your legs, what we call them. So this is a leg and this is a leg. So I can do 5 squared plus 12 squared equals c squared, because that length that I'm looking for, or x, I could really call this x squared, is across from that 90-degree angle, which means it's the hypotenuse. 5 times 5 is 25. Remember, squared does not mean 5 times 2. It means 5 times itself that many times. Plus 144 equals x squared. $25 plus 144 is 169. Square root both sides, x equals 13. Questions about that? All right, let's move on to problem number 5. Oops, 4B. Let's move on to problem 4B. A rectangle still has a length of 12 centimeters and a width of 5 centimeters. How does the area compare to the perimeter of the rectangle? The area is greater than the perimeter. The perimeter is greater than the area. The area is equal to the perimeter. There is not enough information to compare the area and the perimeter. So having read those answer choices, it helps inform me how I'm best going to solve this problem. The best thing for us to do is to find the area and find the perimeter and then kind of figure it out. So I am going to find my perimeter, which is 12 plus 12 plus 5 plus 5. 12 plus 12 is 24. 5 plus 5 is 10. 24 plus 10 is 34. Now I'm going to find my area. Let's redraw our rectangle again. And labeling both sides 12 and 5. Area is going to be the square measurement inside. So area equals length times width. So 12 times 5 equals 60. Which one is greater? Which one is greater? The area is greater than the perimeter. So A is going to be the correct answer. A teacher gives students a real-world problem to explore different solution strategies before introducing formal procedures. This instructional strategy is best described as direct instruction, inquiry-based learning, drill and practice, or mastery learning. So a teacher is giving students a real-world problem. 2, why? Why are they doing it? This provides us the why. 2, explore different solution strategies before introducing formal procedures. If students do not have formal procedures yet, they are probably not doing drill and skill. Drill and skill is much more of a formal procedure operation. And so if we're doing all of this before we introduce those formal procedures, we are probably not doing drill and skill. If a teacher is giving students a real world problem and exploring a variety of strategies, then they are then they are doing inquiry-based learning. They're not doing direct instruction, because direct instruction would be the teacher standing in the front of the room, saying all the things they need to say, and the students sitting there as good students listening and taking it all in. But by throwing a real world problem at the students, students are being given the opportunity to sit and really question and think about it and build those strategies for themselves. I'm going to skip number 6 because I want to get to a couple of the other problems before we have to close out tonight. We'll come back to number 6 either this week or next week. Alex is purchasing a fish tank from the local pet store. He purchased the fish tank shown below. If the fish he wishes to purchase needs 14 gallons of water per fish, what is the maximum number of fish Alex can purchase? 1 cubic foot is approximately 7.48 gallons. 1 cubic foot is approximately 7.48 gallons. So this is a world of conversions right here. So what we have is a fish tank that is a 3D rectangular prism. What do we know about volume of a rectangular prism? It equals length times width times height. Why does it equal length times width times height? Because length times width equals the area of the base. So for any prism, the volume is going to be area of the base times the height. But in a rectangular prism, the area of the base is length times width. And so we're looking at length times width times height. The fish that he wants to buy requires 14 gallons of water. And they tell us that 1 cubic foot is approximately this many gallons. So my plan of attack is I need to find the volume so I can find out how many cubic feet we have. And then I need to multiply the volume times 7.48 to figure out gallon capacity of the fish tank. So to find the volume, I'm going to do length times width times height. Because multiplication is commutative, which means we can solve it in any order, I'm going to do 21 times 72 times 18. Times 72 times 18. Using my handy dandy calculator, that equals 27,216. 27,216. That is how many cubic inches. However, I'm just realizing that I was like, wow, that seems like a lot compared to my answer choices and how I have to solve this problem. However, what do we notice about that last line? What do we notice about that last line? 1 cubic foot equals 7.48 gallons. What did I just solve for? Cubic inches. So what I actually need to do, and I'm going to keep this work just to show you that, like, sometimes it takes a few extra steps. I need to convert all of these into linear feet. I cannot divide this number by 12 because that is dividing a cubic number by a linear value, and I cannot do that. So I'm going to convert my linear measurements into feet. So I'm going to divide all of these by 12 to get my linear feet measurements. So 21 divided by 12 is 1.75 feet. 72 divided by 12 is 6 feet. And 18 divided by 12 is 1.5 feet. Now I'm going to find the volume using my feet measurements. 1.75 times 6 times 1.5. And that equals 15.75 feet cubed. Now, looking at my plan of attack, I need to multiply that times 7.48 because each cubic foot equals 7.48 gallons of water. And so if each foot of cubic foot equals that much water, I need to multiply. So I'm going to reconnect my iPad and then we will continue on with this problem. It's thinking. Sometimes it does this. I don't like it when it's thinking for this long. All right, it's not wanting to reconnect. So here's what we'll do. I'm just going to flip this around and work it upside down. So I'm going to multiply this 15.75 times the number of gallons, 7.48. That is a conversion factor that they've given us. So 15.75 times 7.48 equals 117.81. What does that number represent? What does that number represent? That is the number of gallons in my tank. So if that's the number of gallons in my tank, what do I need to do now? What do I need to do now? Now I need to divide that by 14. I need to divide that by 14. You say, why are you dividing that by 14? Because each fish needs 14 gallons. So I need to figure out how many sections of 14 gallons are in here so that I can figure out how many fish I'm going to be purchasing. So 117.81 divided by 14 gallons equals 8.415 what? Fish. Now, you and I both know we cannot buy 0.4 of a fish. So how many fish can I purchase? I can purchase 8 fish. I can purchase 8 fish. Why can I not purchase 9 fish? Why can I not purchase 9 fish? Because there's not enough water. If every fish needs 14 gallons, I'm going to do 14 plus 14 plus 14 plus 14 plus 14 8 times. And that's going to equal 14 plus 4 8 times is 112. But then there's not another 14 gallons for that 9th fish to have. In fact, in this case, it rounded correctly. But if this number equaled 8.915, how many fish would I be able to purchase? Still only 8. Because if it was 8.915, I still don't have that whole 14 gallons for that fish to have. I only might have 13 or 12 gallons. And so in that case, I would still have to round all the way down to 8 because in the context of the problem, it doesn't make sense for me to get that 9th fish. So it's important when we're looking at the context of the problem, how we round, because we may not be able to round using normal rounding rules based on the context of what that real story is telling us. Does that make sense? All right, let's try to reconnect this iPad one more time, and then we'll go from there. There we go. All right. Beautiful. All right, let's go on to the next problem. A cake company is building a cake structure for an event. They need to create a pyramid that is then truncated at the top, shown in the image. What is the volume of the bottom truncated portion of the pyramid? What is the volume of the bottom truncated portion of the pyramid? All right. So in this case, again, I'm going to try to figure out a plan of action before I start to solve. I'm going to try to figure out my plan of action before I begin to solve. So I know I'm dealing with pyramids, which means my volume formula is 1/3 length times width times height. Okay. We're at length and width is your base. And then height is the height of your actual pyramid, which is what drops from the top down. It is not your slant height, which is what most people, that's one of the errors that they are going to make. And we only want the volume of this part down here. We only want the volume of this part down here. So what am I going to do? I'm going to find the volume of the big cone, and then I'm going to subtract the volume of the small pyramid, and that will give me the yellow highlighted portion. Okay? So volume of the big pyramid equals 1/3 length 5, width 7, height 18. That was pretty straightforward. So 1/3 times 7 times 5 is 35 times 18. I'm gonna pull out my calculator now. A question you might have is, what if I don't have the volume formula? Like, what if I don't know what the volume formula is? Fear not, no worries. If you're solving this kind of problem, you probably have some sort of reference sheet that allows you to understand that. 35 times 18 equals 630. And 630 times 1/3 or divided by 3, same thing, equals 210 feet cubed. Now, volume of the small. One-third, length, 1.5, width, 3, height. Now, this should have an arrow pointing right here because otherwise it could look like 4 is the slant height, but that is the actual height. Now, what if that was the slant height, but they gave us the height of this yellow part and they said that it was 14. in that case, then you would have to do the 18 minus the 14 to get the 4. And sometimes you'll see some of that kind of problem solving that you'll need to do. So 1/3 times 1.5, 4 times 3 is 12. Use my calculator. 12 times 1.5 divided by 3 is 6. And now all I have to do is 210 minus 6, and I get 204. Fun problem, isn't it? All right. We are about out of time for today. Let me know in the comment box. Don't forget that I'm taking notes on what you want to see me go over next week. So let me know in the comment box what you want to see me go over in the upcoming weeks. I am happy to include that kind of stuff for you. And if you have any further questions, let me know. I look forward to seeing you next week for our next episode. It'll be July 4th week. So some of you may be traveling or out of town, and that's okay. But I look forward to seeing you next week for our next episode of Wednesday Night Math Night. I'm going to turn it back over to Dr. A for some closing statements, and I will see you all next week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.